Picture the North Pole in the heart of winter, a vast, frozen expanse where the sun barely rises and temperatures plunge to unimaginable lows. Above this icy landscape, something extraordinary is happening in the atmosphere. A swirling mass of frigid air, invisible to the naked eye, but powerful enough to shape the weather for half the planet. High above the surface, in the upper layers of the atmosphere, these air currents spin relentlessly, forming a gigantic, spinning dome of cold that hovers over the pole. This phenomenon is known as the polar vortex, a colossal cold whirlpool contained by fierce winds in the stratosphere, circling the Arctic like a moat around a frozen castle. These powerful winds, called the polar night jet, race around the Arctic at speeds that can exceed 100 miles per hour, acting as a barrier that keeps the coldest air locked in place, far from the more temperate regions to the south. When the vortex is strong and stable, it acts as a protective shield, trapping the cold air over the pole and ensuring that winters in Europe, North America, and Asia remain relatively typical, cold, but not extreme. But if the vortex weakens, the winds lose their grip. The once contained cold air can then escape, spilling southward in massive waves that sweep across continents, bringing sudden and severe cold snaps to places unaccustomed to such extremes. This isn't a storm descending from the Arctic, but rather a dramatic shift in the planet's atmospheric boundaries, a rearrangement of the invisible walls that separate frigid polar air from the milder air to the south. When the vortex is stable, the Arctic cold remains locked away, isolated from the rest of the world. But when it's disrupted, those gates open wide, and the cold surges out, sometimes reaching as far as the southern United States or deep into Europe and Asia. Occasionally, the vortex doesn't just weaken, it wobbles or even splits into two, sending frigid air careening into the mid-latitudes. This can trigger dramatic weather changes, from blizzards and ice storms to record-breaking cold waves that disrupt daily life. So the polar vortex is less a monster lurking in the north and more a guardian of the cold, one whose strength or weakness determines whether winter is mild or wild. Its stability or disruption is the deciding factor in whether the cold remains locked away in the Arctic, or whether it invades our daily lives, bringing with it the chaos of extreme winter weather. So, when you hear about the polar vortex in the news, it's not because it's coming for you like a storm, but because it's lost control of the cold it usually guards so well. That's when meteorologists sound the alarm, and cities prepare for a deep freeze. The cosmic dance of the vortex is a key driver of winter weather, influencing everything from snowfall totals to the timing of spring thaws. Its every move matters, not just for scientists, but for anyone who wants to understand why winter can be so unpredictable. By understanding the polar vortex, we take the first step toward decoding the wild swings of winter, unlocking the secrets behind the coldest days, the fiercest storms, and the ever-changing patterns that shape our seasons. Now, let's rise 30 kilometers up, into the stratosphere, the polar vortex's home. This is a region of the atmosphere that most of us never see, but it plays a crucial role in shaping the weather we experience down on the ground. Up here, the air is thin, cold, and swirling in a powerful, invisible current that circles the pole like a giant atmospheric moat. Suddenly, the stratosphere heats up by as much as 50 degrees Celsius in just days. This isn't a gradual change. It's a dramatic, almost explosive burst of warmth that can catch even seasoned meteorologists by surprise. The temperature spike is so intense, it's as if someone turned up a cosmic thermostat over the pole. This is a sudden stratospheric warming, or SSW, a rapid, dramatic event that destabilizes the vortex. SSWs are among the most powerful and mysterious phenomena in atmospheric science, and they can have ripple effects that reach far beyond the polar regions. Imagine blasting a spinning top of cold air with a giant hairdryer. The temperature contrast fades, the winds slow, and sometimes even reverse. The once stable vortex begins to wobble and break apart, losing its grip on the frigid air it once contained. This disruption is like a shockwave, sending signals through the entire atmosphere. The vortex's protective fence collapses, and the cold air it once contained is set free. This cold air, previously locked away over the pole, can now surge southward, bringing the potential for extreme winter weather to regions far from the Arctic. This breakdown isn't instant. It starts high above and takes about 2 weeks to reach the surface. During this time, the atmosphere is in flux, with energy and momentum cascading downward, layer by layer, until the effects are finally felt at ground level. The process is a top-down chain reaction. The fever breaks in the stratosphere, and the consequences trickle down to our weather. Each layer of the atmosphere responds in turn, amplifying the changes and setting the stage for dramatic shifts in wind patterns and temperature. SSWs are the main trigger for polar vortex disruptions, setting the stage for cold air outbreaks. These outbreaks can lead to record-breaking cold snaps, heavy snowfall, and even unexpected winter storms in places that are usually milder. The reversal of winds is a clear sign. The vortex is breaking apart. When meteorologists see this reversal, they know that the atmosphere is undergoing a major transformation, and that the weather on the surface is about to change in a big way. Once stable, the circulation shatters, and icy air is ready to spill south. This is when the polar vortex loses its strength, and the coldest air on Earth can escape, traveling thousands of kilometers to bring winter's bite to new regions. The lag between the stratospheric event and surface impacts gives us a crucial window to prepare. This window, often lasting a week or two, allows meteorologists to issue warnings and communities to brace for the coming cold. Meteorologists watch for these signals to predict major winter shifts. By tracking the stratosphere, they can anticipate when and where the cold air will strike, helping to minimize disruption and keep people safe. The SSW is the atmospheric dominant that starts it all. One event at the top of the world can set off a cascade of changes, ultimately shaping the weather for millions of people. When it happens, the countdown to dramatic weather begins. The clock is ticking, and meteorologists race to interpret the signals and warn those in the path of the coming cold. Understanding SSWs is key to forecasting the wildest winter extremes. By unlocking the secrets of the stratosphere, we gain the power to predict and prepare for the most intense winter weather our planet can deliver. Timing is everything in the atmosphere. Timing is everything in the atmosphere. Timing is everything in the atmosphere. Most SSWs happen in December or January, but this one struck in late February, an unusual and powerful twist. The reversal of stratospheric winds this late is nearly unprecedented, making this event off the charts. As the Arctic begins to brighten, displaced polar air now collides with regions starting to warm, fueling volatile weather. The late timing means sharper temperature swings and more complex storms. This disruption challenges our understanding of the polar vortex's seasonal rhythm. Instead of fading quietly, the vortex is breaking apart in spectacular fashion. The final act of winter could be its most dramatic, rewriting what we thought possible. Meteorologists are watching closely, as this rare event pushes the boundaries of climate science. The atmosphere's surprises remind us. Winter's not over until it's truly over. What shatters the polar vortex? Giant atmospheric waves, Rossby waves, rising from the lower atmosphere. These waves, generated by mountains and temperature contrasts, surge upward when high-pressure systems over the Pacific and Eurasia intensify. This year, powerful waves are slamming into the vortex, breaking it apart. When these waves reach the stratosphere, they release heat and physically distort the vortex, stretching and splitting it. The vortex, overwhelmed by this energy, fractures into smaller lobes. Forecasts show one lobe drifting over Siberia, another toward Canada and the US. The Arctic's cold is no longer contained. It's on the move. The invisible hand of atmospheric waves has broken the Guardian's grip. The drama above is about to hit home. What happens high in the atmosphere doesn't stay there. It has a direct impact on our daily lives, shaping the weather we experience right outside our doors. As the polar vortex unravels, the consequences are about to become very real for millions of people. With the vortex broken, frigid Arctic air is free to surge south, potentially into Siberia, Europe, or deep into North America. This isn't just a minor shift. It's a dramatic release of cold that can travel thousands of miles, reaching places that might not be prepared for such a sudden chill. The result? A high chance of prolonged, severe cold in the coming weeks. Temperatures can plummet far below seasonal averages, turning cities and towns into icy landscapes and making even short trips outdoors a challenge. Expect not just a cold snap, but a deep freeze, with increased risk of major winter storms. These storms can bring blinding snow, howling winds, and dangerous conditions that test the limits of our infrastructure and our resilience. The clash between polar air and milder air fuels heavy snow and ice, disrupting millions of lives. Roads become treacherous, commutes are delayed, and daily routines are upended as communities scramble to cope with the onslaught of winter weather. Even regions outside the direct path will feel the ripple effects as the jet stream buckles, bringing wild swings in weather. Some areas may see rain turn to snow in a matter of hours, while others experience sudden thaws followed by rapid refreezing. Weather whiplash, rapid temperature changes, becomes the new normal. One day you might be bundled up against bitter cold, and the next, you're surprised by a brief, almost spring-like warmth, only for the chill to return just as quickly. The calm is over, the cold is on the move. Winds pick up, clouds race across the sky, and the landscape transforms as Arctic air sweeps in, leaving little time to adjust. The final weeks of winter could be the most memorable and challenging yet. Emergency crews are on alert, families hunker down, and communities brace for whatever the season throws their way. Now is the time to pay attention to forecasts and prepare for a major shift. Stock up on essentials, check in on neighbors, and stay informed, because when the weather changes this quickly, being ready can make all the difference. The stratospheric warming event has set the stage for winter's grand finale. The atmosphere above has written the script, and now, we're all part of the unfolding story below. All eyes are on the sky as the Arctic's cold air descends. The next chapter in this winter saga is about to begin, and its impact will be felt by everyone, everywhere. We've seen the consequences of vortex disruptions before. In 2018, the beast from the east brought Siberian air to Europe, paralyzing cities and infrastructure. In 2021, a similar event sent Arctic air deep into Texas, crippling the power grid and leaving millions without heat. These events show a clear pattern: stratospheric disruption, then severe cold 2 weeks later. The current setup in February 2026 looks eerily familiar. History warns us, these disruptions can test the limits of our infrastructure and resilience. The real story isn't just about cold, it's about how society copes. The beast from the east and the Texas freeze are lessons in preparedness. What happens in the stratosphere can reshape life on the ground. The stakes are high and the risks are real. A sudden Arctic plunge exposes our dependence on a stable energy grid. When cold hits after mild weather, energy demand spikes, just as supply falters. The 2021 Texas freeze showed how quickly systems can fail: frozen gas wells, iced turbines, and widespread blackouts. This risk isn't unique to Texas. Grids across North America and Europe are vulnerable. A single failure can trigger rolling blackouts or even grid collapse. These events highlight the urgent need to winterize infrastructure. The deep freeze is a stark reminder: our technology is still at the mercy of the planet's atmosphere. As this story unfolds, here are 4 key terms to know. Polar vortex, the high-altitude whirlpool of Arctic cold. Sudden stratospheric warming, SSW, the rapid stratospheric heat-up that disrupts the vortex. Jet stream, the fast-flowing air current that steers storms and separates cold from warm air. Blocking high, a stationary high-pressure system that can trap cold air over a region. When the vortex breaks down, the jet stream buckles, and blocking highs can lock in the cold. These terms are your guide to understanding the coming weather chaos. Stay tuned. Knowing the language helps you follow the action. Is climate change to blame? Not directly, but it's changing the backdrop. The Arctic is warming twice as fast as the rest of the planet, altering the dynamics that drive the vortex. A warmer world means more moisture in the air, leading to heavier snow and messier storms when cold air surges south. These disruptions are now happening in a new climate context, with more volatile swings and unpredictable impacts. Each event is a real-world experiment, helping scientists refine their models and improve forecasts. The ability to predict these shifts weeks in advance is a triumph of modern science. This late-season SSW will test our understanding and forecasting tools. Nature's power is humbling, but our knowledge is growing. The story of the polar vortex is still being written, and we're learning with every chapter.